Hi everyone, I am Prasad. Welcome to Professor Spark channel. This is 11th class for Electrostatics chapter. Let's go to discuss about the uniform electric field and solving the problems related to uniform electric field. See, uniform electric field is created by two parallel plates, which one has positive, other one has negative charge. Suppose total charge is occupied on this plate is plus q and this is the minus q. Suppose unit positive charge is placed here, positive plate repels along this direction and minus attracts along this direction. So unit positive charge is moved towards negative plate for this direction. That means from plus to minus. So it taken as a electric field direction. See here, charge is uniformly distributed on this plate. Here negative charge is also distributed equal on the plate. So here uniform electric field is created. Further classes we will discuss how electric field is created uniformly between this region. Remember, so electric field is direction from positive plate to negative plate. Suppose electric field is along this direction, mean here positive plate here and here negative plate is here. Charge q is entered into uniform electric field, its direction is changed. Suppose there is a positive charge in a uniform electric field. Due to electric field E, a force is created on the charge, so it is moving towards the negative plate and this is moving with uniform acceleration. Suppose there is a negative charge, so it is attracted toward the positive plate and it is repelled by the negative charge plate, so it is moving towards the positive plate. So here force is created by uniform electric field, so it is moving with uniform acceleration. So whatever the charge in uniform electric field, it is moving with uniform acceleration. Let's go solve some problems. The body which is affected by uniform electric field. Electron and proton are entered into the uniform electric field. What is the ratio of their acceleration? Suppose this is positive plate and this is a negative plate. Suppose this is the electron and this is the proton. Mass of electron is me, mass of proton is mp, charge of electron is minus e, charge of proton is plus e. So negative charge is moving towards the positive plate, so electron is moving along this direction and positive charge is moving towards the negative plate, so this is moving along this direction. The electric field here, that is suppose it is E. So force on electron due to electric field F is equal to EQ. Charge of electron is minus E. So here minus is the direction, so it is not considered here. According to Newton's second law, F is equal to ma. So mass of electron is me and acceleration of electron is ae. So that is equal to E into E. So acceleration of electron is E into E by me. So this is equation 1. Now come to the proton. Now force on proton due to electric field. So F is equal to EQ, charge of proton is E, and F is equal to ma, so mass of proton is mp, acceleration of proton is ap is equal to E by mp. So what is the question here? What is the ratio of their accelerations? So this is equation 2. So you want to ratio, that means division. So AE by AP, that is equal to, see here, E into E by ME by E into E by mass of proton. E cancel. So 1 by ME by 1 by MP, that is MP by ME. So this is the ratio of accelerations of electron and proton which are moving in uniform electric field. You know, mass of proton is 1837 times is greater than the mass of electron. So mass of 1837 into ME. So ME cancel, then we get 1837. So acceleration of electron is greater than acceleration of proton by 1837 times. Deuteron and alpha particle are entered into the uniform electric field. What is the ratio of their acceleration? Deuteron symbol is 1H2 plus, alpha particle symbol is 2He4 plus plus. So mass of deuteron is 2 AMU, mass of alpha particle, that is 4 AMU, charge of deuteron plus 1E, charge of alpha particle, that is plus 2E. Suppose they are moving uniform electric field, so force is created on both. First I take force on deuteron by electric field. So that is F is equal to EQ. So charge is 1E. F is equal to MA. Mass of deuteron is 2 mu and acceleration is AD. So acceleration of deuteron is E into E by 2. Now force on alpha particle by electric field. F is equal to EQ. Charge of alpha particle is 2E. F is equal to MA. Mass of alpha particle is 4 AMU. Acceleration of alpha particle is A alpha. So A alpha is equal to 2E by 4. See here, this is equation 1, equation 2. Question is comparison. Question is comparison of accelerations. Comparison means division. A alpha by AD, that is equal to 2EE by 4 by EE by 2. 2 1 ja, 2 2 ja. 2 2 cancel, EE cancel, then we get the answer is 1. So both alpha particle and deuteron are moving with the same acceleration in uniform electric field. A charged body Q having mass m is entered into the electric field E with velocity v. If the body is moving with retardation in a straight line, how much time that body will return to the same position? Suppose uniform electric field is along this direction. That means plus plate is here and minus plate is here. Plus Q is moving with retardation, mean going on its velocity is decreasing. So it is moving from negative plate to positive plate. Force on the charge is along this direction. So its velocity going on gradually decreases. So it is moving with retardation. Now question is, how much time that body will return to the same position? So now charge is entered with velocity v in uniform electric field. So it is moving in opposite direction of electric field. So force acting on the charge is in opposite direction. So its velocity going on decreases and finally somewhere it is stopped. Now charge returns to the initial position. So whenever it covers initial position, its displacement is 0. So displacement is 0. Initial velocity is v. What is acceleration? F is equal to q. So electric field is E and charge is Q and F is equal to ma. So mass is given. So acceleration is equal to EQ by m. So acceleration is equal to EQ by m. Now what is the question? What is the time? This concept is related to the kinematic equations. In kinematic equations we have a formula S is equal to ut plus half at square. So displacement here 0, initial velocity is v, so time is a question mark, plus half, acceleration is minus eq by m because it is moving retardation, plus into minus. When this term become towards side, then it become positive. Vt is equal to half eq by t square and time cancel. So time is equal to 2 Vm by EQ. So it will take time 2 Vm by EQ to reach the initial position point. A charged body of mass m is in equilibrium in an uniform electric field E, which is in upward direction. How many number of electrons are lost or gained by the body? A body has a mass m and charge is not clearly given. It become positive or negative. So due to it has a mass m, it has a gravitation force mg in downward direction. Electric field is given, that is in upward direction. So plus plate is in downward and minus is in upward direction. Body is said to be equilibrium, mean other force which is equivalent to the gravitation force should be act on the body opposite to the gravitation force. Positive plate repels positive charged body in upward direction. So body should have positive charge. Suppose its charge is Q. So electrostatic force is EQ. In equilibrium, mean So both forces are equal. EQ is equal to mg. So what is the Q here? That is mg by E, and Q is positive charge. So this is a plus. So Q is positive charge means it has loss of electrons. How many electrons are lost by that body? That means Q is equal to, what is the formula? Ne. So Ne is equal to mg by E, implies N is equal to mg by E into E. So this is number of electrons lost by the body. A spherical body has a charge minus q, radius r, and mass m is moving down with uniform velocity v in uniform upward electric field E. Find coefficient of viscosity of air. See here, body has a mass m. That means it has a gravitation force is in downward direction. So its gravity force is mg. Is a charge has minus q. Electric field is in upward direction. That means, so here positive plate here and negative plate here. Negative charge attracted toward the positive plate. So electrostatic force is in downward direction. Electrostatic force, that is equal to E minus Q. See, minus is a downward direction, so its magnitude is EQ. Viscous force, we know, when the body is moving down. When the body is moving down, so viscous force is in upward direction. Viscous force. Formula 6 pi n RV. Body is moving with uniform velocity, so acceleration 0. When A is 0, force is also 0. So total force on acting body is 0. That means upward force is equal to downward forces. So upward force is viscous force, downward forces is gravitation force and electrostatic force. So viscous force is equal to mg plus EQ. So what is the viscous force? That is 6 pi n RV, that is equal to mg plus EQ. So now question is, what is the, find the coefficient of viscosity. So this is the question, that is equal to mg plus EQ by 6 pi RV. So this is answer. Two charged bodies Q and minus 2Q having masses m and 2m respectively are initial at the same place in uniform electric field E of two opposite charged parallel plates of a distance d. If two charged bodies are reached in the same time to the charged plates, what is initial position of two charged bodies from positive charged plate? Electric field, two charged plates which are separated at distance d. So this is, suppose this is a plus plate, this is a negative plate. So here initially Q and minus 2Q are at the same point which have masses m and 2m. Minus 2Q is moving towards the positive plate and positive charge is moving towards the negative plate. So both are reached in the same time. So both are moving with what acceleration? First you go to calculate, say acceleration. That means force acting on charge Q. is EQ. So F is equal to what? MA. Mass of Q is M. So acceleration of charged Q, suppose AQ, then AQ is equal to EQ by M. Now force on minus 2Q, that is equal to EQ. So EQ means E into charge minus 2Q, but minus is not taken here because I want only magnitude. So force is 2EQ and force is equal to MA. What is the mass? That is 2M. Acceleration is A to M. So here 2 cancel. Acceleration to M is equal to EQ by M. See here both accelerations are same. EQ by M, EQ by M. So both reach at the same timing. So both are started exactly at the midpoint of parallel plates. Or both charges are at the distance d by 2 from positive plate. Two charged bodies Q and minus Q having masses m and 2m respectively are initially at the same place. Suppose I take this is the initial position of Q and minus Q whose masses are m and 2m. This is a positive plate and this is a negative plate. Now minus Q is moving toward the positive plate and plus Q is moving toward the negative plate. So force on Q, that is equal to electrostatic force is E, so EQ. Force on Q, that is MA, so mass is M and A, acceleration of charged particle, that is AQ, is EQ by M. So this is equation 1. Now other equation is force on minus Q, that is equal to E into minus Q. So I don't take here minus because I want to only magnitude, that is EQ. F is equal to MA. So mass of the minus Q is 2M and acceleration of minus Q is A minus Q. So A minus Q is equal to EQ by 2M. So both acceleration are not same. Given total distance is d. Initially both are at a distance x from positive plate. That means from negative plate it becomes d minus x. See for positive charge. So displacement is x, acceleration is EQ by m, initial velocity in rest position u is equal to 0 and suppose time is t. For minus q, displacement is d minus x, acceleration is EQ by 2m, initial velocity is 0, both times are same, so this is also t. See these values. So what is the suitable kinematic equation for this one? That is S is equal to ut plus half at square. See u is 0, so this term is 0. Half, what is a? That is EQ by m into t square. What is s? That is x. See for this one, S is equal to ut plus half at square. So u is 0, so this term becomes 0. Half a, half into a mean EQ by 2m. S mean d minus x. So this is equation 1, this is equation 2. Look here. So what is the now question? What is x? So question is, at which distance from positive plate? So x is question mark. Observe these two equations. X is variable, time is variable. X is variable and this is time is variable. So we want to eliminate time with the help of both equation. So clearly t square is eliminated by dividing equation 1 and 2. So 1 by 2, that is x by d minus x, that is equal to half eq by m into t square by half eq by 2m into t square. So half of cancel, e cancel, q cancel, m cancel, t square cancel. So 1 by 1 by 1 by 2. So that is 2. Take cross multiplication. Then we get x is equal to 2 into d minus x. So x is equal to 2d minus 2x. So minus 2x bring towards this side, x plus 2x. That is equal to 2d, x plus 2x. That is 3x. So x is equal to 2d by 3. So x is equal to 2d by 3. At a distance 2d by 3 from positive plate, we get initial position of both charges.